In question 4 of this exercise, we are given a bunch of these word problems, 5 word problems, and in each case we have to form the pair of linear equations that models the given situation, and then we have to find the solution by any algebraic method, either by substitution or elimination or using the cross multiplication method. So let's start with the first part. So in the first part, the question says a part of monthly hostel charges is fixed and the remaining depends on the number of days one has taken food in the mess. When a student A takes food for 20 days, she has to pay ₹1000 as hostel charges, whereas a student B who takes food for 26 days pays ₹1180 as hostel charges. And we have to find the fixed charges and the cost of food per day. So the two unknowns in this situation are the fixed charges. So let's assume that the fixed charges are ₹F for fixed, and the other unknown is the cost of food per day. Cost per day, so let's call it rupees, let's represent it by C. So the two unknowns are F and C, and now using the given information we have to set up a pair of linear equations in F and C. Now the first piece of information says when a student A takes food for 20 days, she has to pay ₹1000. So this is student A, and for student A she has to pay ₹1000 if she takes food for 20 days. So for 20 days the cost she will incur is F being the fixed cost, and for 20 days she will have to pay 20 times C as the cost per day times 20 days, and the total cost she has to pay is F plus 20C, and this should be equal to 1000 because she pays ₹1000. The second piece of information which is given for student B, this says that student B takes food for 26 days and she pays 1180. So for 26 days she will have to pay a fixed charge of ₹F, and for 26 days a cost of 26 times C, and this will mean a total cost of F plus 26C, and this is equal to 1180. So these two equations are the pair of equations in F and C, and now we can solve them and find the values of both F and C. So because the coefficients of F are equal in the two equations, let's use elimination to solve this pair of equation. So what we can do is let's call the first equation 1 and the second equation 2, and let's do 2 minus 1. So we subtract the first equation from the second equation. What will we get? The F terms will cancel out and we will have 26C minus 20C on the left hand side. So 26C minus 20C on the left hand side, and on the right hand side we will have 1180 minus 1000. So 1180 minus 1000. So this gives us 6C is equal to 180, and hence C is equal to 180 by 6 or 30. So we found the value of C. Now we can substitute this value of C into any equation to find the value of F. So let's substitute this value of C into the first equation. So we get F plus 20C. So C is 30, so 20C is 600. So F plus 600 is equal to 1000. And this means that F is equal to 1000 minus 600 or 400. So the answer that we get is that the fixed charge is ₹400 per month, 400, and the cost per day of food is ₹30. And that completes part 1 of this question. In part 2, the question says a fraction becomes 1/3 when 1 is subtracted from the numerator, and it becomes 1/4 when 8 is added to its denominator. Find the fraction. So the unknown in this case is the fraction. In fact, there are two unknowns, the numerator and the denominator of the fraction. So let's say that the numerator is x, and let's assume that the denominator is y, which means that the original fraction is x by y. So this is the original fraction. Now, what are the two pieces of information that will help us set up a pair of linear equations in x and y? Well, the first piece is this one, which says a fraction becomes 1 by 3 when 1 is subtracted from the numerator. So the numerator is x. When 1 is subtracted, we have x minus 1, and the denominator is y. So x minus 1 by y, this becomes 1 by 3. So this gives us our first equation in x and y. So let's cross multiply and write it in the standard form. So we get 3x minus 3 is equal to y, and I can write this as 3x minus y minus 3 is equal to 0. So this is the first equation that we get in x and y. Now the second piece of information for x and y comes from this statement, which says the fraction becomes 1 by 4 when 8 is added to its denominator. So the numerator is x, and if we add 8 to the denominator, the fraction becomes 1 by 4. So from this we can get our second equation in x and y. Let's cross multiply, and we get 4x is equal to y plus 8, and let's write it by bringing all terms to the left side. So we get 4x minus y minus 8 is equal to 0. So these are the two equations in x and y. Now let's solve them and find the values of x and y. We see that the coefficients of y in both the equations are the same, minus 1. So we can simply subtract the two equations to eliminate y and get the value of x. So the technique we'll use to solve this pair is elimination, and let's call this first equation 1 and let's call this second equation 2. So let's do 2 minus 1, and what will happen when we do 2 minus 1? So on the left side the y terms will cancel out and we'll have 4x minus 3x. So 4x minus 3x, and we'll have minus 8 minus minus 3. So minus 8 plus 3, and this on the right side we will have 0, and this will give us 4x minus 3x is x, and x minus 8 plus 3 or x minus 5 is equal to 0. So x minus 5 is equal to 0 or x equal to 5. And now we can use this value of x in any of the two equations and get the value of y. So let's substitute this value of x into the first equation. So we get 3x, so that's 15 minus y minus 3 is equal to 0, and this gives us y is equal to 12. So we conclude that the original fraction is x over y, which is 5 over 12, and we can verify that our answer is correct. If so, 5 by 12 is our answer. If we subtract, the problem says a fraction becomes 1 by 3 when 1 is subtracted from the numerator. So if 1 is subtracted from the numerator, we get 4 by 12, which is 1 by 3. So that aligns with this first piece of information. And if we add 8 to the denominator, the new fraction becomes 5 by 20, which is 1 by 4, and that aligns with the second piece of information given to us. So the original fraction is 5 by 12. In part 3, the question says Yash scored 40 marks in a test, getting 3 marks for each right answer and losing 1 mark for each wrong answer. Had 4 marks been awarded for each correct answer and 2 marks been deducted for each incorrect answer, then Yash would have scored 50 marks. How many questions were there in the test? So clearly the two unknowns in this situation are the number of correct and the number of incorrect questions that Yash got. So let's say that the number of correct answers, or right answers is x, and let's say that the number of incorrect or wrong answers is is y. So x and y are the two unknowns, and we need to set up a pair of linear equations in x and y using the given information. So the first piece of information says that Yash scored 40 marks, getting 3 marks for each right answer and losing 1 mark for each wrong answer. So this is the first piece of information. So because he got x correct answers, he would have received 3x marks for his correct answers, and because he got y incorrect answers and he lost 1 mark for every incorrect answer, a total of y marks would have been deducted from his total score because of his incorrect answers. So 3x minus y should be his total score, and this should be equal to 40. So this is the first equation that we get in x and y. Now the second piece of information says, had 4 marks been awarded for each correct answer and 2 marks been deducted for each incorrect answer, in this case he would have received a total of 4x marks for his correct answers, and his score, from his score a total of 2y marks would have been deducted for his y incorrect answers. So his total score would have been 4x minus 2y, and we are told that this would have been a score of 50. So 4x minus 2y should be equal to 50, and this is the second equation that we get in x and y. Now we have a pair of linear equations. All we need to do is to solve it and find the values of x and y. So let's use substitution in this case. So from the first equation we have 3x minus y is equal to 40, and from here I can write y in terms of x. So y is equal to 3x minus 40. Now let's substitute this into the second equation. So the second equation is 4x minus 2y equal to 50, and instead of y let's write this expression in x, and so we get 4x minus 2 times, and instead of y let's write 3x minus 40, and this is equal to 50. Now this is an equation in x alone. Let's solve it to find the value of x. We will get 4x minus 2 times 3x, so minus 6x, and minus 2 times minus 40, so that's plus 80, and this is equal to 50. And from here we get 4x minus 6x or minus 2x, and 80 I can take it to the right side, subtract it from 50, I get minus 30. So minus 2x is equal to minus 30, or x is equal to 15. So we get the value of x as 15, and if we substitute this value of x into this expression for y, we will get y is equal to 3x minus 40. 3x is 45, so 45 minus 40 is 5. So y is equal to 5. So the answer we get is the number of correct answers is 15 and the number of incorrect answers is 5. So the total number of questions is 20. The question asked us how many total questions were there in the test. So the answer is 20. Now let's quickly verify if our answer is correct. So Yash got 3 marks for every right answer, which means he got 45 marks for his right answers, and he lost 1 mark for every incorrect answer. So he lost 5 marks for his incorrect answers. So 45 minus 5 is 40. So that aligns with the first piece of information given to us. Instead, if he had obtained 4 marks for every right answer, he would have obtained 60 marks for his correct answer, and he would have lost 2 marks. If he had lost 2 marks for his incorrect answers, he would have lost 10 marks in all for his 5 incorrect answers. So he would have obtained a score of 50, and that aligns with the second piece of information given to us. So our answer is correct. The correct answers were 15, the incorrect answers were 5, and the total number of questions on the test were 20. Part 4 in this question says, places A and B are 100 km apart on a highway. One car starts from A and another from B at the same time. If the cars travel in the same direction at different speeds, they meet in 5 hours. And if they travel towards each other, they meet in 1 hour. What are the speeds of the 2 cars? So in situations like this, it is always very helpful to draw figures that represent the situation. So for example, here I have drawn this figure for you, where you see these two places A and B that are 100 kilometers apart, and these X and Y are the two cars that are at places A and B respectively. So the first piece of information in the question says, if the cars travel in the same direction, they meet in 5 hours. So if they travel in the same direction, so suppose that both X and Y, both of these cars travel towards the right like this, then they meet in 5 hours. So they'll meet somewhere to the right of point B. So let's say they meet here in 5 hours. And this will help us form an equation in the unknowns. But what are the unknowns? So the unknowns are, of course, the speeds of the two cars. So suppose that the speed of car X is X kilometer per hour and the speed of car Y is Y kilometers per hour. And from this situation, from this fact that the two cars meet at some point to the right of B in 5 hours, we should be able to form an equation in X and Y. So what is that equation? Well, it's quite simple once you are able to visualize it from this picture. So let's call the point at which these two cars meet, let's call it point C. So what will be the distance of point A from point C, this distance? So this will simply be the distance that car X travels in 5 hours, because they meet up after 5 hours. So the speed of car X is X kilometers per hour and the time is 5 hours. So this distance from A to C should be 5x kilometers, because distance is speed times time, speed into time. So x kilometer per hour into 5 hours, or 5x. Similarly, the distance from B to C, this distance, this should be the distance that car Y travels in 5 hours, and this distance will therefore be 5y hours, 5y kilometers. So we have the distance from A to C as 5x kilometers, and we have the distance from B to C as 5y kilometers, and we note that the distance from A to B is 100 kilometers. So from here we can make an equation easily in X and Y. We note that AC, or 5x, minus BC, or 5y, should be equal to AB, or 100. So 5x minus 5y equal to 100 is our first equation. If I divide by 5 on both sides, I will get x minus y equal to 20. So this is our first equation in X and Y. Let's write it here. X minus y equal to 20. Now let's use the second piece of information given to us, which says that if the cars travel towards each other, they meet in 1 hour. Okay, so let's model this situation now. So in this figure, the two cars travel towards each other. So let's say like this. So the speed of car X is still X kilometers per hour, and the speed of car Y is Y kilometers per hour, and they will meet somewhere between A and B. So let's say some point here, and let's call this point D. And we know that they reach this point in 1 hour, because they meet in 1 hour. Now, what equation can we form in this situation? So we note that the distance from A to D, this distance should be the distance that car X travels in 1 hour. So this will simply be X kilometers. Speed X kilometers per hour into time 1 hour, so that's X. And similarly, the distance from B to D, this distance, this should be equal to Y kilometers. The speed Y kilometers per hour times the time 1 hour. So this should be Y kilometers. And we also know that the total distance between A and B, this is equal to 100 kilometers. So from here, the equation that comes up is quite straightforward. X kilometers plus Y kilometers should be equal to 100 kilometers, or X plus Y should be equal to 100. So this is the second equation that we get in X and Y. Let's write it here. X plus Y equal to 100. Now all we need to do is we need to solve this pair of equations, x minus y equal to 20, x plus y equal to 100, and that will give us the speed of the two cars. So to solve this pair, we can simply add them, because that will eliminate y, because we have a minus y in the first equation and a plus y in the second. So let's add these two equations. We will get 2x equal to 120, or x equal to 60. And from x equal to 60, let's substitute this value of x into any of the two equations. Let's substitute this into the second equation. X plus y equal to 100, which means that 60 plus y equal to 100, or y is equal to 40. So what is the answer that we get? We get x equal to 60 and y equal to 40. And hence the speeds of the two cars are 60 kilometers per hour, this is the faster car, and 40 kilometers per hour, this is the slower car, and this is our answer. Part 5 of this question says the area of a rectangle gets reduced by 9 square units if its length is reduced by 5 units and breadth is increased by 3 units. So we are told that the length changes by a certain amount, 5 units, reduces by 5 units, and breadth increases by 3 units, then the area reduces by 9 units. Also, if we increase the length by 3 units and increase the breadth by 2 units, then the area increases by 67 square units. Find the dimensions of the rectangle. So we have to find the dimensions of the rectangle, which means that the unknowns are the length and breadth of the rectangle. So let's assume that the length of the rectangle is L units, and let's assume that the breadth of the rectangle is B units. Okay. Now, again, to help us understand what this problem really means, it will be very helpful to draw a visual model of the given situation and the given information. So here's a visual model corresponding to the first piece of information. We have this shaded rectangle, which is our original rectangle, whose length is L and whose breadth is B. And now the problem says when the length is reduced by 3 units, so length is reduced by 3 units into L minus 3, like this, or actually length is reduced by 5 units, not 3 units. That's the first piece of information. And the breadth is increased by 3 units, so the breadth becomes B plus 3. Then the problem says that the area gets reduced by 9 square units. So the original area is L times B, length times breadth. The new area will be of this rectangle with red boundary. The new area should be L minus 5 times B plus 3. And what the problem statement tells us is that the area reduces. So the new area is lower than the original area by 9 units. And we can write this as LB is equal to L minus 5 times B plus 3 plus 9. So let's simplify this and see what we get. So we have LB on the left side. On the right side, let's expand this product. So we have LB times L plus L into 3, so 3L. And then we have minus 5 times B, so minus 5B. And then we have minus 5 times 3, so that's minus 15. And then we have this plus 9. Now LB cancels out on both sides, and what we are left with is 3L minus 5B, and then we have this minus 15 plus 9, or minus 6. So 3L minus 5B minus 6 equal to 0. And this is our first linear equation in L and B. Now let's use the second piece of information given to us. If we increase the length by 3 units and breadth by 2 units, the area increases by 67 square units. So again, let's draw a visual model corresponding to this information. So here's one that I've drawn for you. The original length is L. The original length was L, and the original breadth was B. And if we increase the length by 3 units, so the new length becomes L plus 3. And if we increase the breadth by 2 units, so the new breadth becomes B plus 2, then the area increases by 67 square units. So the original area is L times B, the new area is L plus 3, times b plus 2, and the new area is 67 units more than the original area. So LB plus 67 should be equal to L plus 3 times B plus 2. Now let's simplify this, and that will give us the second equation in L and B. So we have LB plus 67, and on the right side let's expand this product. So we have L times B, and then we have L times 2, so that's 2L, and then we have 3 times B, so that's 3B, and then we have 3 times 2, so that's 6. And once again the term LB cancels out on both sides, and we are left with 2L plus 3B plus 6 and then minus 67. So we'll have to write it as minus 61 equal to 0. So this is the second linear equation in L and B. So now what we have to do is we have to solve this pair of linear equations and find the values of L and B. So the two equations we got are 3L minus 5B minus 6 equal to 0 and 2L plus 3B minus 61 equal to 0. So let's solve this pair of equations using, let's say, elimination. So for elimination, what we can do is we have the coefficient of L as 3 in the first equation and 2 in the second equation. So let's modify these equations so that the coefficients of L are the same. So what we can do is multiply the first equation by 2 and the second equation by 3. So what do we get? So in the first equation modifies to 6L minus 10B minus 12 equal to 0, and the second equation modifies to 6L plus 9B minus 183 equal to 0. So let's call this first equation 1 and the second equation 2. Now what we can do is subtract the two equations. So I can do 2 minus 1, and when I do that, the 6L terms will cancel out. I will have 9B minus 10B. So I'll have 9B minus 10B, and I will have minus 183 minus 12. So minus 12, and this is equal to 0. So this means that 9B, and then we have this becomes plus 10B, so that's 19B, and then we have minus 183 and plus 12, this is equal to 0, or 19B is equal to 171, and this means that B is 171 by 19, that is equal to 9. So B is equal to 9, and now we can substitute this value of B into any of these original equations and find the value of L. So let's substitute this into this first equation, 3L minus 5B minus 6 equal to 0. So from here we get 3L minus 5B, so that's minus 45, minus 6 is equal to 0, and this means that 3L is equal to 51, or L is equal to 17. So we conclude that the length is 17 units and the breadth is 9 units. So let's write it here. The length is 17 and the breadth is 9. So the original area of the rectangle is 17 times 9, that's 153 square units. So let's write it like this, units squared, and then let's verify if this information is correct. If this answer is correct, L equal to 17 and B equal to 9. So let's match it against what's told to us. So if the length is reduced by 5 units, then the new length is 12, and if the breadth is increased by 3 units, then the new breadth is 12, and the new area is 144, which is 9 less than the original area. So this first piece of information checks out. And now if we increase the length by 3 units, then the new length is 20, and if we increase the breadth by 2 units, then the new breadth is 11. So 20 times 11 is 220, and 220 is 67 unit square more than 153. So the second piece of information also checks.